Good morning, everybody. Welcome to the 2021 GSHA virtual business meeting and conference. We hope you enjoy our presentation over the next 2 days. Please be sure that you are muted and your video is off, and I see that everybody has done that. Questions will be taken at the end of the presentation using the chat box only. Since we have probably about 14 people, we can probably turn that part on, and we'll maybe ask questions with you by audio, and it'll go a little bit better and quicker. So without further ado, I'm going to ask Dr. Lee to get on with his presentation, which is called the Big Y-700 DNA Foundations.
All right, thanks, Tom. Welcome, everyone. Welcome to the conference. Hoping you're having a great time, and I'm sure you'll have a great experience this weekend. Welcome to Big Y-700 Foundations. So we have a lot to talk about in a very little bit of time. And those who have watched me in the past know that that's always what I say, right? There's so much to talk about. This is a big kind of topic. So these are the 7 questions that I'm going to go after. What is DNA? What is a mutation? What is Y-DNA? What is the Big Y DNA test? How can I leverage genealogy with the Big Y? What's next for Y-DNA research, and how can I participate? All of that in over a little an hour. So we will be moving at a pretty good pace here. All right, that said, because I don't have time to really deep dive, I have 3 videos out there at the FACC GSHA website, parts 1, 2, and 3. That's like 3 hours and 45 minutes worth of content on this topic. So if you want to dive deeper into anything, I invite you to go there. I may mention a video, one of these as I present today, and direct you there for more information, since there's not time to dive into everything. All right, so we're going to do a little chemistry 101, and I promise to keep this super painless and simple. So what we have here is an oxygen atom. And so you can see you have your protons and neutrons are in the middle, and you have electrons on the outside. So that's all you need to know. We have atoms. Those are really basic building blocks, right? And then a molecule is when you combine multiple atoms together. And so in this case, you have 2 hydrogen atoms combining with an oxygen atom. You have which gives you H2O, which is water. So this is a water molecule. So the concept of a molecule is pretty simple, right? Add a couple more ingredients, in this case, nitrogen and carbon, and you end up with a molecule that we all know and love called caffeine. If they had told me this in high school, I would have done better in chemistry class. We're only missing one element here for DNA, and that's phosphorus. So this is what DNA is. DNA is a molecule. Really that simple. Really made up of like 4 base molecules, right? You can see here, and we call them TAGC because we're too lazy to actually see the full names, and who wants to remember all of that, right? And so this, along with carbon as a backbone, and that's all the material you need to create DNA. All right. So we these chemical building blocks, right? G, A, T, and C. And they're really pretty simple because they connect to each other in a very predictable way. So as you can see, they connect. And so T always connects with A, as you can see here on the right and down here on the left. Conversely, A always combines with T. G always combines with C, and conversely, C always combines with G. And you can see there that on the left here. What that means is if I were to use my magic wand and turn you into a molecule and say, your job is to unzip this and make a copy of both of them, you could do it pretty easy, because if you unzip this and you know that there's a T, well, you just reach into your toolbox, you grab an A and click, and that's really that simple. So that's what DNA is. And then these strands are paired up and wound into larger structures called chromosomes. And humans have 23 pairs of chromosomes. So have you guys heard of the product 23andMe, well, that's what they're referring to, right? Those 23 chromosomes. And so a genome is the complete set of genetic information. So these 23 chromosomes make up the genome, and the genome is the complete set of information. The 23rd chromosome is the sex chromosomes, right? So women have 2 X chromosomes, men have 1 X, 1 Y. So it's the dad that determines the sex of the child, right? You're going to get an X from mom because that's all she has to give you. And you could get an X from dad, in which case you'll be a girl, or you could get a Y from dad, in which case you'd be a boy. So it's the mutation on the Y chromosome that we're going to be talking about today, and how we use that for genealogy. And before we get too far down this and you're thinking, well, I'm a woman, this is not for me. That's not true. Y chromosome testing can be used by anybody, and just bear with me as we get into that topic. Just keep that in mind. So that's it. That's all the chemistry we need to know. I just wanted to say, what is DNA? Well, DNA is a molecule that stores information about how to build a human being. So the next question is, what is a DNA mutation? So you may have watched a movie, read a comic book where there's a mutation and it gives you like superpowers, but that is pure fantasy. It's not going to give you superhuman strength, and it's not going to allow you to read people's minds. So what is a mutation? Well, when the body makes a new cell, and it doesn't make very many mistakes. I mean, it's unzipping that Y DNA, right? And it's making a copy as it creates new cells, and it's doing this millions of times. And 99.9999% of the time, perfect execution. But once in a while, a mistake is made. So sometimes a single base pair gets either left out or added or substituted. And so it's this last type of mutation, a single base pair substitution occurring on the Y chromosome, that we're interested in today. So this single base pair substitution creates a type of mutation called a SNP, or single nucleotide polymorphism. And SNPs are the mutation that autosomal DNA tests like Ancestry.com and 23andMe and MyHeritage, as well as Y-DNA tests, use. So this is the mutation for most DNA tests, except for perhaps mitochondrial DNA. I don't know a lot about mitochondrial DNA testing. There are around 10 million SNPs in the human genome, which account for many genetic differences between you and everyone else. Sometimes it affects like your hair color or what diseases you may develop or how you respond to drugs. But the vast majority, and I don't want to underestimate this comment, vast majority of the SNPs, these single nucleotide polymorphisms, these mutations, have no effect whatsoever on you. And these are the type of mutations we're talking about for DNA. So DNA mutations, they don't even affect like your hair color or your eye color or how tall you are, anything like that. But we can use them as markers. All right, so the mutations are important to understand because that's really where the power of DNA comes from. And the right Y chromosome of all the different DNA tests, type of tests, uses it the best, in my opinion. So Y chromosome is passed along mostly unchanged from father to son, and mostly unchanged is important because if it moved and never changed, then we couldn't use it for Y DNA. There would be no signals for us to follow. Some mutations do occur, and just often enough to be useful. So key SNP mutation rates in the Y chromosome are predictable enough to be used to provide rough estimates for time to most recent common ancestor. That's very important for genealogy. I'll be mentioning this a little bit later, but there are 2 different types of DNA tests. There's the lower level DNA tests, and they don't use SNP mutations, okay? Only the higher level Y-DNA tests, like the big Y, use the SNP mutation. So for now, I just want to clarify that. The SNP mutations are more stable and are easier to use for time to most recent common ancestor calculations than those lower level Y-DNA test where you're using genetic distance to do that. And that's just a ton of work. We'll go into that later. So they provide breadcrumbs. I call them breadcrumbs. That can be followed from the present day all the way back to the beginning of mankind. So Y-DNA allows you to go back hundreds, thousands, and tens of thousands of years, about as far back as our Homo sapiens. That's how far back you can go. So I call Y-DNA, these upper level Y-DNA tests, like the big Y, the Goldilocks mutation, because it mutates just often enough to be helpful, not too slow, because if it's too slow, then you're going, many hundreds of years before another mutation happens, and that's hard to follow. Too quickly, well, I don't know if too quickly is a problem, but we'll talk about how autosomal DNA falls off a cliff, and this one doesn't do that. So this has like all the benefits that you see of the different kind of DNA tests, with none of the weaknesses. So Y-DNA is just, as far as genetic mutations, Y-DNA just nails it. All right. Because of the rate of these SNP mutation changes, right, Y-DNA mutation can be used to construct a high-resolution family tree of mankind, even without knowing anything about a person's genealogy. So with Y-DNA, let's say you are R, and I'm going to use the Martinez family as an example today because they're so big, and everybody probably has a Martinez on their genealogy somewhere on their tree, whether you found it or not. So I'm going to use them as an example. If you're a Martinez and you don't have much of a genealogy for your Martinez line, but you take the big Y test, you're going to know which of the sons that you fall under from the originator, and we'll show that a little bit later. So you can get a ton of information, even if you don't have genealogy, to be able to track things. Now, this depends upon the team, and we'll talk about that later as well. The test is only as good as the team. So if you have no one taking the test from your family or from your area, then you're not going to have a lot of data. But if you have a ton of people taking the test, the more people that take the test, the more powerful this kind of test is. So this allows the researcher the ability to solve investigatory questions in near genealogical time. And if you want to see a really good case study of that, watch my first video. And it can go back as far as you want without limit. So if you have a question from 200 years ago, this will knock it out. 300 years ago, no problem. 1,000 years ago, it doesn't matter. It's just as strong, no matter how far back you go. All right, so there are three main kinds of DNA tests. There's autosomal DNA, which is the most popular kind of DNA, mitochondrial DNA, and then Y-DNA, and there's two kinds of Y-DNA tests, like I mentioned. One that uses SNP mutations, and one that does not. So I'm going to quickly go over those five just to kind of do a quick comparison and contrast. And yes, I have a major bias, and I've always admitted that. So, excuse me. So I'll start with autosomal DNA. So autosomal DNA is the most popular type of DNA test, right? It's the one that most people have or will tend to have. I have them listed here by size. So Family Tree DNA has Family Finder, which is their autosomal DNA test. And then MyHeritage is, their database is twice as big as Family Tree DNA. And then 23andMe, their database is twice as big as MyHeritage. And then Ancestry DNA, their database is twice as big as 23andMe. So it's literally, so these are the top four, but each one is twice as big as the one. And when it comes to autosomal DNA tests, the size of the database really is really relevant. There's really no difference in technology and chemistry, and there's no real difference between these other than the size of the database, and the size of the database is a huge deal. So here's the deal with these kind, right? These are cheap, right? You can get these for like $59 on sale. So they're easy to give us gifts. They're relatively easy to understand. They don't really require a great deal of expertise to interpret. And they're great if you are like adopted and don't know who your parents are, or you have an adoption or other non-paternal event in your family line that you're trying to figure out in the past, 3, 4, 5, 6 generations. So it's really good for genealogy for that time frame. The problem is, as you can see here, as my gummy bear friends are trying to demonstrate, is the concept of recombining, which means that every generation, its power to help you with genealogy is cut in half. So that by about 5 generations or so, about 200 years, this test is not able to help you with genealogical questions. So if you're like me and you already have a robust 5 genealogy chart and you're solving problems farther out than that, this isn't going to be able to help you at all. So here's a good example. And it's important to understand that you have 2 family trees, right? You have a genealogical family tree that includes everybody. And then you have the genetic family tree, which includes the people that you inherit genes from. And so if you can see here, the people in green, you're inheriting genes from. And this is like the edge on the left-hand side, this fan chart is the edge of autosomal DNA. You go 1 more generation back, you're not getting genetics from anybody. So ethnicity estimates, and I know this is off topic a bit because I'm talking about Y-DNA, but ethnicity estimates is something you get from autosomal DNA. It's important to know that it isn't an estimate of your full genealogy. It's not an estimate of all your ancestors, right? It's a ethnicity estimate of the folks that are covered. So for example, the folks in green here, you would be getting ethnicity estimate information from them, but the folks in white or the ones in blue here, you're getting nothing, right? So you could have, you know, a Native American line in one or many of those white lines and yet show up as 0% Native American. But you could be 20% Native American, 5% Native American, never know it because it's not catching it. All right. And then you can see on the right-hand side what I'm talking about. Once you get to about 5th cousins, this is the percent that's able to get. And then after 6th cousins, it just falls off a cliff and you can't really get a lot of genealogy out of it. So let's talk about mitochondrial DNA really fast. So I have my confirmed Y-DNA haplogroup on the upper left. Excuse me. And confirmed is important. Only a SNP type of Y-DNA test can give you a confirmed haplogroup. Those lower level Y-DNA tests like the Y-37, the Y-67, the Y-111, they don't give you haplogroups. They can estimate a haplogroup, but when they do that, they're leveraging SNP testing data to do that. And then you can see on the lower left here, I have my confirmed mitochondrial haplogroup. So let's compare them. So if you can see here on the top, these are the breadcrumbs I'm talking about, right? So I have 1, 2, 3, 4, 5, 6. QM3 is crossing the Beringia land bridge 15,000 years ago into North America, right? Most Native American men are QM3. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, this is covering, 25,000 years. Now let's look at mitochondrial DNA breadcrumbs. 1, 2, 3, 4. That's it. So B2A2, which is my haplogroup, that's a Pueblo line. That's about 10,000 years old. It's a subbranch of B2A, which is 12,500 years old, which is a subbranch of B2, which is about 17,000 years old, which is a subbranch of B4. B1 which is about 25,000 years old. This is 150 years old, and this is me. This is 53 years old. So to look at the level of detail, I can go just as far back as mitochondrial DNA. I can go hundreds of years, thousands of years more into the present than mitochondrial. So that's why I say the Goldilocks test. Y-DNA is just easier to work with. Now, does that mean that you can't use mitochondrial DNA for genealogy? Well, it depends on the family you're in. So for example, in New Mexico, if you're an A2H1 lineage that connects with Maria de la Cruz, you're good to go. There's a ton of information, but I can only count on maybe my one hand, like 2 or 3 lines like that, where people are talking about, oh, this is amazing. But then it's radio silence out of that. My own, like I said, I have a 200 years worth of genealogy on my mitochondrial line and my genealogy, and I still can't get some value out of it. So some people can, it's just harder. and you're less likely to find people who are getting value out of the mitochondrial DNA than the Y-DNA. Again, did I mention I have a bias? So just throwing it out there. But again, look at the number of breadcrumbs compared to this. Look at the time frames compared to this, and then make your own decision on that. Another issue I have with mitochondrial DNA is it's kind of reached at the edge of its growth, right? The full sequence, full package test that you're getting today is exactly the same as the one from 2005. There have been some innovations that have allowed it to become cheaper. So there have been changes in technology so that it's more affordable, but as far as the actual product, it's the same exact product as from 2005. Whereas the Y-DNA, as you can see on the left, every couple of years, it makes this quantum leap of value and focus. I expect in another couple of years, we'll have a big Y-1000 and we'll have a bit more information. All right, so does that mean that I don't value all these different DNA tests? It doesn't mean that at all. As you can see here, I have autosomal DNA from family tree DNA, which is called Family Finder. I have mitochondrial DNA. As a matter of fact, I have 2 autosomal tests I've taken. I've taken this one because it's integrated with my Y-DNA mitochondrial. All this is integrated together. And I've taken the ancestry test. So I have all these tests. So I'm not saying you shouldn't do them. I'm just saying that if you go to a carpenter and you ask them, oh, show me your favorite tools, and I pull out my favorite power tool, I'm simply saying that the big Y test is my favorite power tool. Yes, I have a hammer, I have nails, I have a saw, I have all kinds of tools, and I use them all the time. But then I have my power tool. And so that's what my presentation today is on. So this here is the new interface for Family Tree DNA. It might look different from others because you can actually move it around and make it look the way you want it in a way. But here, as you can see, we have the lower level Y-DNA tests. You have the SNP-based Y-DNA tests, and like I said, autosomal and mitochondrial. All right, so focusing on Y-DNA. So every man on the planet carries a Y chromosome, right, which was carried by his biological father and that father's biological father and so forth. And as it's passed down, a record of all previous mutations, and I want to stress that, all previous mutations gets passed along as well. So remember those breadcrumbs? Those breadcrumbs all the way back, tens of thousands of years, are in me. And then when I pass it to my son, he gets all of those, plus any new mutations that it may have happened. So let me just show you really quickly what I mean by that. So QFT5172, this is a family clade. That means that this is only about 150 years old, and there are probably people on this call right now who fall under this family clade because they fall under this man. On average, every 83 years, generally speaking, a new mutation happens. Well, that's what this is. This is me. So what happens is that my dad has this mutation and this mutation and this mutation, this mutation, and all of these going, and it keeps going, right? But my son has all the things that my dad has, plus he has this mutation. Oops. He has this mutation. And my grandson has this mutation. And if my great-grandson, if I were to ever have a great-grandson were to get a new mutation, he would then have all of these mutations plus the new mutation. So see what it means? You carry within you the full history of your paternal line. That's what makes Y-DNA so amazing. It goes all the way back to Y Adam. So Y-DNA testing is leveraging these signals, right, these breadcrumbs, to piece together a giant ancestral tree representing the genetic paternal ancestry of all men on the planet called the haplotree. It looks like this. Now I talk about the haplotree and my opinion, and that my opinion is that it's growing, well, it's clearly growing unevenly, as you can see here. And I believe that is based on socioeconomic factors. So R1b right here, this is Western Europe, right? You have Eastern Europe, I1, this is Sweden, I2 is Romania, Serbia, Croatia, Bosnia, Herzegovina, Kosovo, and Macedonia. E, this is North Africa. And then, okay, so where's sub-Saharan Africa? Well, right here. You can barely see it. Where's the rest of Africa, which is landmass wise incredibly huge? Where's the Native American lines, right? I mean, you can barely see it right here. So there's a direct correlation between rich nations and the growth of the haplotree. That's all I'm saying. And so you can see these are the dominant haplogroups. Unlike autosomal DNA that shows you something like this, right? So, oh, look, you're 65% Spanish Portuguese, and here's Spain and Portugal, right? This actually shows you the migration path through time of that Y DNA. So it's more refined, right? It'll tell you, oh, you're on the Q main branch, and QM3 is a mutation that happened 15,000 years ago, and now you are QFT5172, and that comes from Western Mexico, and now it's in Santa Fe. So that's the level of detail you get. So here's, for example, my Sanchez line that's based from like Bosque Leiden area, Llano Largo. So this is that line, and you can see, I can tell you from Africa where it has migrated over time, thousands of years. Here's my Trujillo line. Now, notice the difference. This is our haplogroup. This is a J haplogroup. Notice the difference in that my R haplogroup has far more detail, right? Look, it tells you exactly how it's getting to Spain. Whereas this one is like, well, you're here in like the Ukraine, and then hundreds of years later, you find yourself in Spain. Well, where's the, clearly they didn't, where's the path? Well, why is that? Well, here's why. Here's R, here's J. See the difference in size? So that's why the difference in detail. So just like anything else, Y DNA is like other DNA tests, where the more data you get, the bigger the database, the more fidelity you get, the more detail. All right, so like I said, we have two types of DNA products. You have the lower level DNA that does not use SNP mutations, and that's the Y12 through Y111. And you can't even buy the Y12 or Y25 anymore. Those are obsolete. You really start at like the Y37 is your entry. And then there's the big Y, which is a SNP-based mutation test, which is the higher level test, which is my focus today. Just be aware that when you buy the big Y700, you get everything. So if you buy the big Y700, you get the big Y and you get the lower level. You get all of this with this one test. So when you buy the big Y, you're actually getting two tests, because there are two different tests. Different chemistry, looking at different type of mutations, double work. So it's actually, as expensive as the big Y is, it's actually pretty good value. Bang for the buck, it's the best one. Granted, it's more expensive, but it is the best value for the money, is to get the big Y, because again, you get the full thing. All right, so these are the two types of mutations I was talking about, those lower level tests, which were the tests that were available like the first decade of the century, right? The year 2000, 2011. These were the tests. These are based on, these mutations are different. I haven't introduced these mutations yet. And these are STIR mutations, or short tandem repeats. And I'm going to show you what that looks like. And it's important to know that, because when you get the big Y again, you're going to get all this data, and you want to be able to use all this data. All right. So this is what a STIR mutation looks like. So let's say I have 4 people, and they take the Y12 test. I know we don't even offer the Y12 test anymore, but let's say for argument's sake that we did. You can see that what it is that a short tandem repeat is like a stutter, right? CTA, GA, GATA, GATA, 8 times, and then it changes. So the concept of genetic distance, in this case, all things being equal, meaning that of the 12 markers, only one marker, this marker right here, whatever, let's call it marker 4. Let's call it DYS391. That's a marker. So let's pretend that this is the marker. These two folks would have 0 genetic distance, because look, they match in all 12 lines, including this marker. But this kit number 2 has a 1 genetic distance to this folks, and this has 2 genetic distance. So that's what genetic distance looks like. So here we have the Y12 profile for the Martinez family. This is real data, right? So this is that fourth marker, DYS391. All right. So let's talk about genetic distance. So genetic distance is only relevant for these lower level tests. And so you can see that based on the test that you took, you're allowed to have so many genetic distances that we just defined, right? This example, the differences in the repeats. And if you have more than 3 at Y12, they're like, you're not related, right? If you have 2, you're only possibly related. And you have 1, like the example I showed. So here, these 2 people, right? 1 genetic distance would say that they are probably related. And here, this person to these 2 people is only possibly related, okay? And then this is like the cutoff. If you're, the more markers, 12 markers, 25 markers, 37 markers, 67 and 111 markers, the more genetic distances you're allowed to be able to be related or not, right? So at Y111, the biggest lower level test, if you have more than 10 genetic distances, then it's like you're not related, right? So this is the Martinez family, the Martinez family, that have all taken the test within one of the projects, and we'll talk about projects later. So you'll see here's this person has at Y12 2 genetic distance, right? This 11 and this 32 is different from most of the others. So 2 genetic distance, like we just talked about, says that's only possibly related. But then let's say that person then takes the Y37, they upgrade, and there's a third, and there's a new genetic distance, a 3rd genetic distance. Well, now they've taken the Y37, they have 3 genetic distance, they've moved from only possibly related to being related. So what happened? Well, because they upgraded to a higher level test, they have more fidelity. The Y12 could only tell you, oh, there's a possibility related. But the Y37 was powerful enough to say, yeah, you're related. So that's what that means. All right. So we have 40 testers here. And I do want to point out that I can tell who's taken the big Y test because they're in green. These are confirmed haplogroups. And the ones that are in red are estimated haplogroups. And estimated haplogroups like RM269, that's 20,000 years old, or thousands of years old. While these other haplogroups here are hundreds of years old. Then we call these family clades. So that's the difference. If you're, you have to spend, it's like what, $450 for a big Y test. But what you get is, assuming you have a big enough team and you have a big family like this that have taken the test, you're going to get a haplogroup, a branch that's within genealogical time and therefore helpful for genealogy. If you take a lower level test, you're going to end up with a estimated haplogroup that's thousands or tens of thousands of years old that's not helpful for genealogy. So you get what you pay for with these tests, right? All right. Okay, so how do I get this data, right? Where, Lee, on that page that you showed us, your homepage at Family Tree DNA, do I get this? And the answer is you don't. This actually doesn't come from a Family Tree DNA's product offerings. I get, if this were me, I get this data, this me, and that's all I get. I don't get all this data. This is someone else. These are 40 other people, right? So how do I get access to this? You get them through projects. And that's one of the things that makes YDNA or Family Tree DNA of the different kind of companies, as far as genealogy, so much more powerful than the others. This is dated information. So there's over 11,000 group projects at Family Tree DNA. You have surname-based projects, so there's a Trujillo project out there. You have haplogroup projects like QM3 project. And most of the ones I'm in are geographical projects. For example, New Mexico Genealogical Society DNA project. These are led by volunteer administrators who are usually looking to further their own research. So for example, for the New Mexico Genealogical Society's DNA project, that's Miguel Torres. He's the project administrator for that geographical project, right? They're free. Most of them are really easy to join. You just click a button, and some of them have you ask a couple questions. Miguel's project, New Mexico Genealogical Society's project, is a little smaller than some of the others because it's harder to get into because there's more forms to fill out. You have to provide like your best guess genealogy or the best you have. You have to fill out a permission form, but that project provides far more services than the others. So, and I'll show you a little bit on that later. So just be aware of that. So where do I get to these projects? Well, right here is the project section. If you first get it, you're going to have no projects here. You'll click this join a project button and it will bring out those 11,000. You're like, 11,000, how am I going to get through that? First of all, it's going to look at your confirmed haplogroup. Or if you just took a lower level test, it's going to look at your estimated haplogroup and it's going to recommend like 20 or 30 projects for you based on that. And then it's really filtered really easy. You can go do alphabetical, you can search by surname, you can search by like geography. So it's not hard to find a project. Once you've picked all the projects that you want to join, and here's you can see a partial list. You can get to these projects by either just clicking it, or if you want more detail, you can click manage projects. So let's do that. I click manage projects and it's going to bring me to this page. And you can see I now have the same list of projects, which are a fit for my paternal line, which is a native Mexican native line, right? So sure enough, the kind of regional geographic based projects fit. And of course, I'm in one mitochondrial DNA project because there are some mitochondrial DNA projects out there also. Most of them most of the projects are Y-DNA based, but there are mitochondrial DNA projects also. And then here you can set permission levels. So for example, I just upgraded, I'm working with Miguel on my Trujillo line. So I'm donating money towards the project, which I'll show you how to do that in a second. But then I had to give him stronger permissions to be able to help me manage. So I could click in here, open it up and give him full permission. Or I could lock him down and say, I don't want you to have any access to my stuff. And you can do that here. So this gives you your ability to manage what these group administrators can or cannot do with your stuff. So I click on New Mexico Genealogical DNA project and it brings me to the project page. And then if you're not a member, there'll be this big join button right here. And oh, by the way, if you were signed into your Family Tree DNA account and happen to just either through Google found this, it'll automatically know who you are. And then you just press, join, and then usually that's it. And then you're in. You can donate funds like I just did last week. But then if I want to get to that Y37 or Y111 data for my matches, I click on DNA results and boom, this is what I get. Now, granted, I'm seeing more than this. I'm seeing everyone, all thousands of people that are on that project. So I have to use Control F to find, or I can do by last name, Control F and enter the last name, and then it'll help me find the folks I want to find. All right. So let's now all of that information, all this information, the projects, right? The projects are based on lower level Y-DNA testing. That's why it's important when you buy the big Y that you get these lower level stuff as well, because all the projects are based on STIR, right? These are STIR mutations, not SNP mutations. So if I click on Y-DNA matches, it'll bring me to my matches page. And so this is my actual matches page. And so this might be my dad. And this is at Y111. So I have other Martinez's that are immediate family have taken this test, but they don't show up here because they've not taken the 111. Maybe they've taken the 37, right? So 111, there's my dad, there's a third cousin, third time removed, and then these are like ninth cousins. And then this guy here this guy predates New Mexico colonial ancestry. But you remember what I said, the very edge of only possibly related is 10, right? Anything greater than 10, they're like, you're not related. Well, I have one of those, right? Here's a 10-step person. And so I've contacted him. I know about where his ancestors are from. It's all super interesting. If you'd like to look into that, watch my second video. I talk about this guy and I talk about all of this stuff. So the big Y-700, the reason it's called 700 is that in addition to those 1 in 11 STIR markers, you get up to 700 markers. Well, up to 700 markers are looked at. Now you're not, and this is a little complicated, so I'm not going to go too much into it, but I can tell you that at least 589 stirs will be looked at. So you'll never see, so like here's my genetic distance for someone who's taken that where it's looked at 700 markers. You'll never see the number 700 because not all markers are readable, but they guarantee that they'll look at least 589. Now I'll tell you, and I've said this before, I don't see any value in those markers from 111, from like 112 up to 600 or whatever. No one's really figured out how to use that for any value. So I don't, this doesn't really tell me anything. But the genetic distance is how you kind of, if you don't, I know these people and I know their genealogy, but what if I didn't know that? Most people don't. They take the test, you're like, oh, look, no one has my surname. That's usually, so this is my dad. I actually had him take the test, but before my dad took the test, when I took the test, yeah, not a single Martinez. So I was like, oh, that's interesting. If you're interested in learning more about that, watch my first video, the big reveal about the big surprise that I got. And so, like I said, you can see what haplogroup you are in. And so I'll point out here, when I talked about the value that you get from the New Mexico Genealogical Society's DNA project, even though it's harder to get into. See these stars right here in front of the names? If you ever see that, that means that the New Mexico Genealogical Society has validated that line. In other words, it isn't like, oh, this guy pulled this from, he went on Google and saw this and just copied it into his, someone at the New Mexico Genealogical Society has actually gone in and looked at the baptismal records and the marriage records and have said, yep, we confirm that this is an accurate record. And that's helpful to know. I'll talk about the genealogy later, the genealogy charts. All right. So here now I move from 111 markers to 37 markers, and you'll see I have more people, right? Than I had before. Last time I only had my dad. Now I have my dad and an uncle, and a third cousin, third time removed, and now I have another third cousin, third time removed. That's brother of this one, and so and you'll notice that the genetic matches will change. But again, at 37 markers, I get less wiggle room than at 111. At 111, remember I had a person with a 10. Here, if I had a person with a 10, it wouldn't show. Even a 6 wouldn't show. But you can clearly see that easily everyone kind of fits pretty easily at 37 markers. All right, so this is something I don't have time to get into, but it is in I think it's my first video, maybe my second video, that basically says that family tree DNA considers those 111 markers genetic distance. They consider every marker equally. But I know that that's not true. We know that here are the markers for the first 67, right? Here's the 37 test, the 67 test, and these are all the marker names. And here they've ranked, right? We've ranked the speed, the average speed of those mutations. So that means that if it moves really fast, it's not really good for genetic distance. And so I could have a genetic distance of 3 with somebody, but if those 3 markers happen to be one of these very fast markers, I consider it a genetic distance of 0. I ignore those 3. What's very helpful is like marker 6 or marker 8 or marker 9, right? Marker 44 or 45, right? These are helpful. But this is, you notice I was gonna enter in all 111, which would have been very helpful for you folks that have lower level tests. But I'm telling you, I got lazy. It's too much work, because who cares about genetic distance? Get the big Y. And then you don't have to worry about genetic distance. Genetic distance becomes irrelevant because there's a better way to figure out time to most recent common ancestor than this. It's just too much work. So that's my segue to the big Y. Big Y it's not an upgrade to the to the lower level tests, even though it looks like that when you go and it'll say, oh, if you upgrade from Y-111 to the Y-700, it costs this much. Well, it's not technically an upgrade. It's a completely different test. Remember, these are SNP mutations. These are STIR mutations. They're not even the same chemistry. And this is where the power is. This is where the real value, and this is where genealogy can really help out, in my opinion. All right. So I don't have time to go into all the tools, but if I click on the block tree, this is the sandbox box that I work in. And so FT DNA does an in-house analysis of your Big Y test results and presents them on the Big Y block tree, which is what you get for customers, or the haplotree, which is what you get for the public. These are both exactly the same information. So here you have QL663, and here's QL663, which is the father branch or mother branch, whatever, of this one, right? Which is the mother branch of this one. Yep. Which is the mother branch of this one, which is so forth. So it's basically the same. But just to put this in perspective, this private variant here, this little turquoise, that's me. And then this represents my father, my grandfather, my great-grandfather. This represents my fifth great-grandfather. This SNP mutation represents Nicolas de Espinosa, who is the progenitor of the Espinosa family of New Mexico, which is here. Yes, I discovered that my surname actually is Espinosa, and then an Espinosa with a Martinez on a woman, and then we became Martinez early on, like early 1700s. I would not have known that without this test. If I hadn't taken, now for the record, it was a lower level test that gave me that information. It wasn't the big Y, it was actually a Y-700 that allowed me to say, oh, wait a minute, there's no Martinez's on my matching list. There are all these folks that have a most recent common ancestor here that said Nicolas de Espinosa, star, validated genealogy. Let me go take a second look. Again, that's my first video. I get into detail on that. So a reminder again, Y-DNA SNPs are what drives the big Y. All right, so let's talk about the mechanics of the big Y tree. So this is basically a genealogy, if you will, a genetic genealogy of SNP mutations. Each one of these is a SNP mutation. Okay. And this is why instead of genetic distance, what we do is we know that the average time between SNP mutations and time is about 83 years. So if I want to date a branching point, I can simply add these up, multiply it by 83, and it'll give me an estimate of the time to most recent common ancestor. So much easier and so much more accurate than worrying about genetic distance. That's such a blunt instrument. So these are called block of equivalence. I don't have time to explain what that means. I spent an entire hour talking about that in video 2. But just know that that means that a block of equivalence means they're considered to be equivalent age, which means it's complicated, but it basically means we don't know the order of these mutations. Did this one happen first and this one second and then this one third? We don't know. So it's just a pile of mutations right now until further tests come to break this up and put it into more detail. Let's see. So at the head of every block of equivalence is the SNP mutation that represents that block, and that we call that a haplogroup, right? Haplogroup here, haplogroup here, haplogroup here, haplogroup here. So when you get your haplogroup, that's what it's talking about. These are called, these SNP mutations are also called named variants. They're mutations that have been named, right? So we know they're in a database. We know what family tree DNA is aware of them. Here, these are unnamed SNP mutations. These are unknown. These are known. These are unknown. So this line here, this is the Espinosa family in New Mexico. They have, on average, there's 4 testers so far. Of those 4 testers, between them, they average 2 private variants. So one might have 2, one might have 3, might one have 1, might one have 4, one might have 1, and altogether they average 2. But this is unknown to science. This is unknown, and they'll take additional tests to get that forth. Sometimes, like in this instance here, and this instance here, you have a father-son situation. So this is my dad took the test, and I took the test, and this is me. So that means that there was a SNP mutation. Remember, every 83 years it's going to happen. I have a mutation that my dad doesn't have, my uncle doesn't have, my cousin doesn't have, my brothers don't have. And so this represents me. And then this person here, this is two brothers that took the test. So one brother had a mutation, the other brother didn't. But this average of two, this represents 300 years. So anyway, this is just the mechanics. There's a lot going on here. The bottom line is this: if you want to get into the big white DNA and it looks overwhelming, don't worry about it. Just call me. Send me an email. I'll help you. And I do this all the time. I'll help you interpret your results. I'll help you develop a testing strategy. And of course, no charge, right? It's totally free. I do this for fun. All right. So you can use genetic distance, like here, 3 genetic distance compared to like the modal numbers, right? Up to 6, right, at Y-37. But all we can determine from this data here, knowing all the genetic distance, is that they share a common ancestor. We know all these people share a common ancestor because, yeah, this is 3 within 37, right? And up to 6, up to 5 within 37, and we're probably related, right? So I know all these folks are related to each other, but how? How are they related? I don't know. Those lower level Y-DNA tests won't tell you. So I know, and I'll show you why I know here in a minute, that this family clade right here is the mother branch or father branch, if you will, of this family clade and this family clade. So I know not only that this person and this person are related, but this person's ancestor is the father of this person's ancestor. So, and this person's ancestor is the father of this person's ancestor. And these 3, here, here, and here, are brother family clades of this. How do I know that? I only know that by getting the big Y and getting the big tree. And then I know, oh, this is the same exact data we just saw right here, is the same data that you have here in green, right? Oops. But now I know that this haplogroup, which is 1,000, 1,300, 2,000 years old, is the father haplogroup of this one and this one and this one and this one. And I know that this haplogroup, this family clade, because this is in genealogical time, is the parent haplogroup of this and this, and so forth. So now that I have this, what's next? Genealogy is next. And this is important, and I always say this. We're genealogists, right? This tool isn't designed to substitute genealogy. It's designed to validate genealogy and to help you solve genealogical questions. So this represents 13 big Y testers. So are all 13 big Y testers going to have a validated genealogy all the way back to whoever this progenitor is of this family? No, but maybe 2 or 3 of them will. And then you take that genealogy and you place it on top, and you place it on top, and you place it on top. Bam. And then you have a genetic genealogy of the Erdar Martinez family. There's a, the New Mexico Genealogical Society put out an article in their journal back in 2016 on this haplogroup. And back then, this was the big news. Well, shoot, just in the last year, right? Tom here, who's moderating this, has been working really hard on this. Most of these branches have come about recently. Look at the fidelity of this, right? These are family clades. If I have no genealogy and I'm a Valdez and I take the test and I end up with this haplogroup, guess what? I know not only that my Valdez line actually becomes a Martinez line, but I know that it goes through Domingo. One test, boom, just like that. And now that will direct my genealogy. Where did Domingo live? What part of the state? Let's work from the top down if I'm stuck from bottom up, right? So genetic genealogy is a team sport, and it's definitely true for high resolution Y-DNA testing like the big Y. What good is having your Y chromosome sequence if you can't compare it to anyone? The value here is that people have done their genealogy and have taken the big Y test, and then they can share it with you. Some customers take the big Y test and discover that they've made many male relatives within a genealogical time frame that they can use as clues to the origins of their paternal line or surname. And I used this family as an example because they're huge, right? but others find that they're pioneers. So if you're, so this is our haplogroup, but what if you're like a Q haplogroup like I was, right? A native line, you may find a very empty environment around you, and that's the way it goes. It's sometimes you're the person, and then you're recruiting people, and you start building things up. Okay, so what does the big Y do? So it provides data to build the Y DNA haplotree, right? That haplotree of mankind. It maps the migration path of the tester's direct paternal line. Remember, I showed you my Sanchez line, that our haplogroup, I could show you from Africa through the Middle East, through Eurasia, across Europe, into Spain, and then across to the New World. Confirms and refines haplogroups. So I was able to show you haplogroups that were tens of thousands of years old, thousands of years old, hundreds of years old, and within a lifetime. Reveals SNPs unique to the tester's family branch. So QFT5172 is a SNP mutation. FT7152 is a SNP mutation that only applies to me, my brothers, my uncle, my first cousins, second cousins, and third cousins. And that's it. Beyond third cousins, that they would not have this. This is a family clade. Only out to like 3 generations is our, and so it gets to that level. It helps to estimate time to most recent common ancestor. And I actually have 3. I have the time to most recent common ancestor. Let's see if I can show it here. Oops, I'm going the wrong way. Okay, I have, this is a time to most recent common ancestor that's about 160 years old. This is a time to most recent common ancestor. I know the name of this person, right? That's about 200 and some odd years old. I know who this is. This is Nicolas de Espinosa. So I have 1, 2, 3 named people, and I know how far back these go. So that's what we mean by time to most recent common ancestor. Well, most recent, depending on how big you're going. Is it just me and my first, second, and third cousins? I know that. Is it me and my 5th cousins? I know that. It's me and my 9th cousins. I know that. And it contributes to research and advancement of science. So why upgrade to the big Y-700? Those of you that have the Y-37 or the Y-67, you're like, oh man, I have to spend another $200. So STIR mutations alone don't define a line. It only shows that matches share common ancestors, like I demonstrated. STIR values only indicate the genetic family. It's the big Y that identifies family lines, like I've shown. And the STIR genetic distance is unstable and lacks accuracy, so only a rough tool. And I give an example of that in my first video. Just a quick recap. I have a person who's a genetic distance of 2 to me, and I have a person that's a genetic distance of 9 to me, and yet on genealogy, they're the exact same distance. So boy, that, you know, it's just too rough for me. Is it valuable? Yeah, it can give you some clues, but Big Y gives you more information. All right, so I want to talk about the family. There's a family tree here. Now, no, I don't think that this family tree would be your new family tree software program. If you have a place where you store your family tree, your genealogy, keep it. But this family tree is integrated into all these tests. And so I use it as a testing, I use it for research purposes, not as a database to store information. I use it to help me do research, and I'll do a quick demo of that. So if I click on my family tree, I can go to a family view, a pedigree view, and this is the pedigree view, and you can see this kind of what it looks like. And then if I click here, it'll bring it out, and it'll show who's taken what test. So my mom's taking the Family Finder test. My grandmother, who recently passed away, took the Family Finder test. My dad's taken the Y-111, and here's family clade. Now, if I go and click tree management, I can see, and again, because I have autosomal DNA testing, it will tell me how I'm related. It calculates. If I were to go in here and go to family tree view and add you, because you're a 3rd cousin, and add your genealogy to my genealogy, it automatically calculates how we're related. And then it gives me my summary statistics. So I have 361 individuals vast majority of which are cousins, not my parents or grandparents or great-grandparents. 35 linked matches, 16 surnames, blah, blah, blah. And then I can email them, make notes, see what tests they've taken, and so forth. Now, this is where I want to point out that the Y-DNA test, you're like, well, that's just one line. I have like hundreds of lines, and that's just one line. Well, that's not true. If you have hundreds of lines, then you have at least 50 Y-DNA tests and 50 mitochondrial DNA tests, because half of all your lines are Y-DNA, and half of all your lines are mitochondrial DNA. So you just think about that. So yes, I have a Y-DNA paternal line, and my haplogroup is QFT5172. But then there's my dad's mom's father, who has a Sanchez line, and that is a haplogroup RBY110455. And then I have my mom's dad, whose surname is Archuleta, and he has a Y haplogroup. And then there's my mom's dad, and he's a J haplogroup. And so I have 4 Y-DNA projects. And I have 1 mitochondrial DNA project, which is my mom's mom's mom. Now, why don't I have this mom and this mom and this mom? Well, I've shown you that mitochondrial DNA, I don't have the time or the resources or the genealogy or the cost of this. Isn't just for me. I'm going to do my own mitochondria, but I'm not going to do the others because it's just for me. I'm not part of those 1, 2, or 3 lines that seem to get a lot of value from mitochondrial DNA. And so I'm only just doing the one. But again, everyone's different. All right, so this is my Trujillo family. And so this is a different kit, right? This is a different account. So I've gone to my maternal grandmother was a Trujillo. So I went to her and recruited her nephew and said, take the test, and I own and control this kit. And so he has his Y-DNA matches. And you can see here that I can tell who's entered in their genealogy within within family tree DNA. This person has, this person has, this person has, but these 3 people haven't. And then there's another. If you see like a thunderbolt down the middle of it, it means that they have it, but they're not sharing it. They keep it private. So what I did for him is I went to the family tree, but instead of putting the family tree like I did for me, I went into family view and I went in. Remember, these are all the Trujillo matches that he has. I grabbed this data because it's shared, right? And I grabbed this data and I grabbed this data. I went through all the Trujillo matches and I built a Trujillo family tree. So this is the progenitor of the Trujillo family of New Mexico, all his known sons based on genealogical research. And then those genealogies I found, I entered them in. At the bottom, there's this link matches. So I go into my Y-DNA. I've only done, well, I just upgraded this a couple of days ago from a Y-67 to a big Y, but at this point, I only have Y-67 data. I can go, and so I have this guy's genealogy that he shared. And then when I was entering it into my tree, when it was time for him, I just grabbed him, dragged it, and dropped it on top of this, and bam. And so now I have, these are the Trujillo matches along with the genealogy. So how is that going to help me with research? Well, if you watch my 3rd video, you'll know that there's a strategic way of selecting people to take the big Y test to maximize your value of your data and to build as many new branches as possible. And one of those is to pick a 4th cousin, patrilineal 4th cousin. How does this help me with that? Well, this is me and my mom and my grandmother. And so these folks are siblings, 1st cousins, 2nd cousins, 3rd cousins, 4th cousins. Guess who got a call last week? This guy did. Hey, dude, upgrade to the big Y-700. I need your data. His data is more important to me than, this person, because he's a 4th cousin. And anyway, no, I don't have time to get into the details. Watch my 3rd video. There's a reason why I'm finding a 4th cousin to take this test.
Lee,
These are, yeah, go ahead.
you have about 10 minutes before the question and answers.
Perfect. I'm right on schedule. So again, there's a lot of detail here I can't get into. That's why I'm referring you to those other videos. But again, you can see how I've leveraged the family tree. I've kind of hijacked the family tree capability of the framework to do it this way. So this is not a typical family tree, right? This is literally become a Trujillo family tree. And I'm going to do the same thing for the Sanchez line. I'm going to have all the Sanchez genealogies I've found so far. I'm going to put it within my first cousin once removed that who I recruited and whose kit I control, and I'll do the same thing for him. And I'll use this as a place to target specific individuals to recruit to take the big Y to meet my needs. All right, so this is the Trujillo big Y so far, and you can see it's broken down into this Cordova line, which descends from the progenitor. This SNP mutation Y144212 represents Cristobal de Trujillo. And then you have all these folks, a Romero, and then 4 Trujillos that have taken the test. And then you have the Cordova line. Well, I'm anticipating that by the end of this year, this is going to have 4 or 5 branches, and it's going to look more like the Martinez one than it does now, because I helped this come along, right? I contacted these folks. Well, a lot of these folks took the test because I contacted them and said, please take the test. And I'm like a gardener, right? I'm pruning the tree, I'm growing the tree, or helping the tree manifest itself. All right. So new user interface. If you look at my first 3 videos, I never really show you what I show you today, which is I'm saying, hey, here's the homepage, and here's where you can go to get to projects, and here's where you can go to click to get to your matches. I don't really show that in those 3 videos because I knew that they were going to redesign the new user interface, which they just did like last month or 2 months ago. So there's a new user interface that you've now seen. There are many exciting new Y-DNA features planned for this year. Ancient and academic samples are being added to that big tree that's helping us. So if you have like Clovis burial information, or you have the Kennewick man, or things like that, that's important, right? They find those Viking graves, and then they find the DNA and they get put onto the tree. Family Finder haplogroups. Right now, Family Finder, which is the autosomal DNA, right now is like disconnected from Y-DNA, but what's coming in the future is they're going to create a capability to help you mine your autosomal matches for your paternal line. That's, I don't know what that's going to look like, but I'm excited to see what that might be. FTDNA will be introducing one of the most anticipated features, which is age estimates. So right now we have to do the math, right? I have to count out those SNP mutations, multiply by 83, and but they're going to put together some kind of new capability where it does some of that work for you. I'm super excited about that. The current haplotree uses SNPs to decide the branching structure, but the branch lengths do not directly correspond to time, so they're going to work on that. Let's see. Oh, and then academic studies. So in order to make the Big Y database more comprehensive and interesting, Family Tree DNA is adding almost 5,000 Y chromosomes from present-day males that have participated in academic next generation studies, including the 1000 Genome Project, the Human Genome Diversity Project, and others. There's tons of studies out there, and so they're pulling in the academics into the database as well. And this is really refining the haplotree. All right, the final topic I have is how can I participate? So if you're considering Y-DNA testing and funds are available, go with the big Y-700. That's the biggest bang for the buck, the most value. Don't be intimidated by it's not designed for the casual user, but I am here. You can email me, instant message me. I have a couple times a month, I have phone call conversations with people, and I'm walking them through their findings and helping them understand and get value. If you're a male, you can get a big Y test for yourself or a male relative. Don't forget that your mom's father has a Y chromosome that can also help. If you're female, you can ask your brother, uncle, or male cousins to test. And again, I've had to ask male cousins to test, right, for my grandmothers. So what if you've taken the big Y already? Be sure you're in a haplogroup project for important information and analysis plus appropriate surname projects. Also, look for those fourth cousins that are patrilineal fourth cousins, so fourth cousins with your same surname, and contact them and ask them to take the big Y test as well, because that's going to help you get more information. If you have taken the big Y-700 test and you have a haplogroup that's older than 400 years old, then yeah, contact me. Well, there's a way to get those haplogroups so that they're within genealogical time, so you can do and use it to help you with genealogy questions. Contact your STIR matches to upgrade. So I have 70, 80 matches, and they hear from me all the time, like 4 times a year. I'm like, hey, it's Father's Day is next week. It's the test is going to be on sale, or hey, look, the big white tree for your surname has grown and added 2 new branches. Take a look. So I do that for my STIR matches. All right, and then Facebook has a ton of groups. This is just a smattering of the ones I'm involved in to one degree or the other. So you can, if you want to learn more, this is how I learned, right? There's Y-DNA group, Facebook groups, Big Y Facebook groups, Genealogical Society groups like the one we're in now. I'm in a bunch of Mexico ones because of my haplogroup is based in Mexico. Anyway, so there's a ton of stuff. The Family Tree Guide to DNA Testing and Genetic Genealogy. Can you see this? This is a good book. And then more advanced, specific to Y-DNA, the Genealogist Guide to Y-DNA Testing and for Genetic Genealogy by David Vance. It's a good book right there. All right, and that's it. Tom, how did I do on time?
Thank you, Lee. You did really good. It's 13 after 12. So we got roughly about 18 minutes till the end. And we can actually go longer if we need to, because I think we're going into lunch after that. Okay. So if anybody has questions, go ahead and unmute yourself and ask a question. I know I've got a few here.
Oh, let me make a correction. My email address is wrong. So this email address that you see there on the screen is wrong. It should be almark24. So Alpha Lima Mike Alpha Romeo Tango ALMART 24 at asu.edu. So it's missing an L. That I does not belong there. So I apologize for that.
Okay, Kristen Linden, I think, do you have a question? Maybe not. Great. Does anybody else have a question? Okay, I'm going to ask a question here. SNPs are more stable. Why is that?
Yeah. So on average, because they mutate at an average even rate. So 83 years, right? Whereas a STIR mutation on those markers, some of them mutate fast, some really fast, some slow, some really slow, right? It's all over the place. Whereas SNP mutations all SNP mutations have an average rate, just one average rate of about 83 years. Now, I explained this in my 3rd video. When I say average, it has a big range. So the farther back in time you go, the more true that average is. The more information you look at, the more true that average is. I've seen lots of examples where a mutation hasn't happened in 200 years. That can happen. Mutations happen randomly, right? It's not like there's a magical clock in the universe that says, oh, time for a SNP mutation. But over time, we have found, or science has found, that the SNP mutations on average are mutate at an even enough rate for us to use roughly for estimates, which is better than what we have for STIR mutations.
Okay, so that leads me to another question. All mutations are in all males in the present from the past. So can a previous mutation change again?
A STIR mutation can, but a SNP mutation can't. So that's another reason why SNP mutations are more stable. A STIR mutation can actually go back. It can go from it can go from 10 repeats to 9, and then a couple generations later back to 10, right? But a SNP mutation, once you have a SNP mutation, it's there forever. It never goes away.
So why is that?
Well, I guess it's based on probability. We have hundreds of millions of what's the probability that that exact letter in that exact place is going to change? I mean, it's just, it's just improbable, right? It can go hundreds of thousands of years. I mean, maybe it's possible, but you're talking about a time frame of millions of years, and it's just not far outside of our,
Okay, so then if projects only use STIRs, how are they good for us then?
Yeah, so I use them to have a broader view of my matches. So remember, I'm cut off. I didn't make that decision, right? Family tree DNA decided, at 10 genetic distance, we're not going to show you visibility of that person. We're not going to give you their information. You don't know who they are. But I can get that through the projects, right? I can see them. And it's a little bit more work because I have to go through the project administrator to get to their contact information. But I've recruited people that aren't a match for me because I'm trying to build my broader tree. So that's a main reason for it right there. And I think that part of it is that it was built during a time when there were no big Y tests, right? So remember, the first 10 years, there was no such thing as SNP Y-DNA testing. So that's when those projects were built. And I think that now you have a community. I think the data is less central now than it used to be, but it's still useful. I don't use them as much as anymore. Now I'm more in the big tree. That's my project area now. And I don't really spend a lot of time in those projects, but I still think you should join those projects because then you're getting to meet people who like a surname project, right? You're part of a surname project, or you might even want to even build a project for yourself. You can be a project administrator. You just contact Family Tree DNA and say, I want to be a project administrator for X, right? I don't know if that helped answer your question.
Oh yeah, it did. Miguel Torres's project is, to me, is more useful because he includes the genealogy part of it in there.
Correct.
Yeah. So just, I had another question that I slipped my mind, but does anybody else have any questions? It looks like you did a really good job, Lee. No questions other than me. I always have questions.
Well, I have a question. So how many people who are attending today have never seen any of my videos before? I'm just curious.
Me.
Who is me?
Lorraine Aguilar.
Oh, okay. So Lorraine, did I lose you? Did you think it was interesting?
I tuned in too late, so I couldn't figure out how to access your talk, but I've been my son was one of the first that tested for the New Mexico project back in 2004 or whatever, anyway. And I did what you did, but I don't go as deep as you, but I got cousins that I've never met. I've got everybody to test, everybody I can.
Break time?
This presentation.
Break time? Almost.
So this presentation has been recorded, so if you're late, you can still watch it.
Yes,
later.
Thank you.
Cool. Anyone else here not see any of my videos before?
Yeah, I haven't. It's Barbara Delgado Gildy.
Hi, Barbara. How did you feel like you learned anything from this presentation, or did I lose you?
No. Well, right at the end, you kind of lost me.
Yeah.
And I have a college degree, but no, it was very, very interesting. I really haven't. I really don't know much about Y-DNA, but I know that it's the next step I need to take to find my great-grandfather. So no, it was very informative.
So I'll let you know that never buy it on when it's not on sale. And it goes on sale all the time. So it's on sale the week of Father's Day. It's on sale the month of August, which we're in right now. It's on sale the month of December, the whole week of Father's Day. Yeah. So those are the times that it tends to be on sale every year. You'll save like 50. You'll save like $50.
Yeah. Well, I did purchase it at during Father's Day, that promotion, and I realized that I need to up it. I need to upgrade it.
What, you got like a Y-37 or Y-111?
I think it was the 111.
Okay. Yeah. So yeah, feel free to reach out to me. Do you know that when you take the big Y, it takes like 3 months for the results to come in?
Okay.
And
Thank
then
you for that.
once you get the results, if sometimes it has to go through manual review, which means there's another like 3 weeks wait on top of that. So that's the hardest part for me, is the wait. It takes so long. Okay. Anyone else not watched my videos before? And that, Tommy, explain why we have so few questions, because those videos are pretty detailed.
Yeah. Those 3 videos, you can watch them on the FACC channel on YouTube. I'm going to go ahead and put the address in the main room on one of the chats for where you can find those videos. They're free to watch. There's 3 of them, and they go into a lot of detail. Lee, even in this video, has I've learned a lot of things from him, even on this video. But Barbara, the DNA out for Y, trying to learn it is just a matter. It's like anything, like a musical instrument. You have to start someplace, and you just gotta just keep going until you learn enough.
Right. Yeah. I think the tree building has been very exciting and very kind of easy for me, but it's the whole DNA aspect has been a little intimidating. So I'm just trying to dip my toe into that now.
One of the real values, I think, of any of the Y-DNA tests is to validate your genealogy. So if you're like, oh, I'm a Sanchez, and I'm like, are you sure? And they're like, well, yeah, I have a genealogy. I have all the birth certificates, and I have the marriage certificates going all the way back. And I'm like, okay. So did you consider that maybe mom had an affair with the neighbor, and the priest that signed that birth certificate didn't know? Did it occur to you that maybe somebody was adopted, or that a mistake was made in the record? Because I can tell you that the experience has been that on average, about half the people who take the test end up with a surname that wasn't their surname they thought they had. I'm actually worse than that. Of my four surnames.
Somebody's playing music.
Of my 4 surnames, my Martinez ended up being an Espinosa. My Sanchez ended up being a Lopez. My Archuleta ended up being a native line, not an Archuleta, and only my Trujillo line ended up matching the Trujillos. So I'm 3 for 4, right? 3/4 of my tests have invalidated my well-designed, well-documented genealogy. So that for me is one of the biggest things that it does. Now, the danger, of course, is some people don't want to know that, and it can be hard news for someone, especially if they're super proud of their surname, and they have a family crest up on their wall, and then the test comes out and it's like, yeah, you're not a Martinez from Spain, you're Espinosa from West Mexico. Well, I didn't care. That was my experience. Not a big deal, but not everyone takes that news so well, right? And I can tell you that I had a really good genealogy, and I was in the right village at the right time. And sure enough, there was a non-paternal event. We had a Nicolas de Espinosa who was fooling around, and the DNA is interesting because we know things that the priest and dad and maybe even mom did not know in the day. There are things we know they didn't know because this is like a paternity test on steroids, right? So it's super interesting. But I tell you that I've had to reconstruct major sections of my genealogy tree because of the DNA results I got from this.
Wow.
So you just had to say, okay, this record is wrong.
Yeah, because I tell you that the chances of DNA being wrong is 0.
Yeah.
And the chances that a wedding record or even more so a baptismal record is wrong, yeah, there's fraud, right? Someone paid someone off to falsify a record. Someone, for political reasons, decided they're going to put something else. Like I said, there was a lot.
Or they just didn't know.
They didn't know. And dad thinks he's the biological father. Mom thinks he's the biological father, but he's not. And so that's where Y-DNA really takes you to that. It's like the ultimate validation. That star that you see. Well, this is a good example. On my Sanchez line, there are two different Sanchez families, both of them with validated genealogy to the Sanchez de Inigo line, which is the line that we genealogists think descend from the priest, Father Munoz, right? Both these Sanchez lines, but they're not connected. The DNA-wise, Y-DNA, they're not the same paternal line, but they both have validated genealogies through Bernardo Sanchez to that line. But they can't both be right. One has to be right and one has to be wrong. My Sanchez line, again, that's based in the Leiden, Bosque area, as well as like Llano Largo. Think about like the Blue Ventures. That Sanchez line, yeah, I have the baptismal record, the marriage record, just like that other family does. So which one's right? So both of them could get that star that says we validate your paper, but the DNA basically says nope, just one of you is wrong, and the paper's not going to answer this for you. You're going to have to figure it out. For me, super exciting because it doesn't really matter, right? It's not like one's a winner and one's a loser. It doesn't matter. Everyone wins by knowing the truth of where you're from. My Sanchez line, the seems to come from our next closest ancestors are living in Russia and Georgia and the Ukraine. How interesting is that? So like, where did that come from? And how did they end up in Spain? And how did that line then end up in the United States? Actually, I'm sorry, that's my Trujillo line. My Trujillo line is Georgia and Russia. My Sanchez line actually comes through Great Britain, across Europe and through Great Britain, and then down into Spain and then across. So for me, that's where I'm trying to, this is my ultimate goal, is I want to know who's the father of Cristobal Trujillo. We don't know. Or who is his grandfather, great grandfather? What part of Spain did he come from? Who's the father of Hernán Martínez Solano I? No one knows that answer. Yeah. What city is he from? I want to know that. And I think Y-DNA can at least tell us what town he is from, because we can find it. You see what I mean? So that for me that's the next step for me. I'm moving beyond New Mexico history and I'm moving farther back. Right now we have a wall. There's a paper wall that's gone. I don't think there's a paper trail to be had. And the only way we're going to answer these questions is through DNA. Well, I want to thank everyone. We're at like 11:30, so I want to thank everyone for listening in on this. And like I said, I'm here. Contact me. Again, my correct email address is almart24@asu.edu, not the one on this page here. Thanks.
Okay, thank you, Lee, very much. Yeah, it's about 12:30 here in Pueblo, but it's lunch right now, and the next speaker session start at 1:30. So thank you, everybody, for attending, and thank you again, Lee.
Thank you.
Thank you so much.
Thank you.
Thank you.
Thank you.